Hi guys and girls, today we are doing simultaneous equations where one of them is a quadratic. It's something that is usually worth quite a few marks in an exam, mostly because it requires quite a lot of algebraic technique. So I've got 3 examples for you. We'll get cracking. So what you're actually doing when you solve one of these simultaneous equations is, if you imagine you've got a quadratic curve somewhere like that and a linear graph, you are finding the 2 points of intersection. Because they're a coordinate, you do need both the x and the y values. Now this is not substitution by elimination, which you're probably used to by now, which is where you make one of the numbers in front of an x or a y the same. This is a substitution type of simultaneous equation. So what we're going to do is we always take the linear one and substitute it in to the non-linear one, so the quadratic. So if this is equal to y and this is equal to y, then I can put this there. So that will give me x plus 4 is equal to x squared minus 4x plus 8. Quadratics have got to be equal to 0 in order to be solved, so I'm going to take away x and take away 4 to give me x squared minus 5x plus 4. And then you're using whatever you can, whether that be factorising, completed square form, or the quadratic formula to solve it. This one will factorise. So we want numbers that add together to make times together to make 4, but add together to give negative 5. So you could use 1 and 4 or 2 and 2. When you times them, they've got to make a positive, but when you add them, you've got to make a negative. The only way for that to happen is if they're both negative. And then you'll say, right, what pair there can I use to make negative 5? And it's the negative 4 and negative 1. So either x is 1, because that's got to equal 0, or x is 4, because that one can equal 0. So we've got 2 x values, now we need y values. So you can sub into either one of those original equations. I would always recommend the linear one. So I'm going to sub x equals 1 into y is equal to x plus 4. So that gives me that y is 5. So the coordinate of one of the points is 1, 5. And then if you do the same, if you sub x equals 4 into y equals x plus 4, that will give me y is 8. So the other coordinate is 4, 8. On to the second one. Similar idea here, we've got a linear one, a non-linear one. I'm going to get a different colour. Now, this top one here, the linear one, is not in a form that is easy to substitute because it's not y equals or x equals. So the first thing we need to do is make it, usually y equals is the best way to do it. So I'm going to add the negative 2 onto the other side to give me y is equal to 4 plus 2x. Now they're both equal to y, I can take the linear one and sub it into here like we did before. That's going to give me 4 plus 2x is equal to x squared minus 10x plus 36. Again, I now need to make them equal to 0. So I'm going to take away 2x and take away 4. So now I'm looking for, I'm going to try factorising again. Factors of 32. So I can use 1 and 32, 2 and 16, 4 and 8. That's going to be it. And I need times together to make positive, add together to make negative. So both of them are going to have to be negative. Then it's a case of which one of those can make negative 12, and it's the 4 and 8. So my two answers are x is 4 or x is 8. And then just like last time, we're going to substitute. It can go into any one of them. It can even go into the one that you rearranged. So that's the one I'm going to go into. Y equals is always going to be the easiest one. So sub x equals 4, what on earth is that, into y equals 4 plus 2x. So that will give me y equals 4 plus 8, which is 12. So one of the coordinates is 4, 12. And I'm also going to sub x equals 8 into y equals 4 plus 2x, which will give me y is equal to 4 plus 16, which is 20. So the other coordinate is 8, 20. Then last one. I'm going to go for another different colour. Let's go blue. So again, this top one is not in a form that I can easily substitute. I would want to make it y equals. So I am going to, I'm going to add the y onto that side and add the 2 onto that side. So if I do the y first, if I add the y on, I get negative 2 plus y. Then if I take the 2 across, I'm going to get x plus 2 equals y. I'm going to take that one and substitute it into here. So that will give me x squared plus x plus 2 equals 44. It's got to be equal to 0, so I'm going to take off the 44 to get negative 42. And I'm going to factorise. Or at least try and factorise. So I've got 42, so I can do 1 and 42, 2 and 21, 3 and 14, 6 and 7. They've got to multiply to give a negative, add to give a positive. Now the only way you can get a negative n number, constant, is if one of them is a negative. And then they've got to add together to give you positive 1 from this bit. So if they've got to add together to give a positive, the bigger number is the one that's got to be positive. So these ones would have to be negative. And which one's going to give me negative 1? It's going to be that one if I add these together. It'll give me 1, positive 1. So that means I've got a negative 6 and a positive 7, which means that x has got to be 6 or x has got to be negative 7. I'm going to sub into my linear equation in the nice easy form. So I'm going to sub x equals 6 into y equals x plus 2, which will tell me that y is equal to 8. So we have 6, 8. Then sub x is negative 7 into y equals x plus 2, which will tell me that y is negative 5. So I have negative 7, negative 5. So the key to this is all about making your non-linear one be y as the subject. then substituting that into the quadratic one. If you try and do it the other way around or try and square both things, it's going to go horribly wrong. So rearrange the linear, substitute into the quadratic. Okay, bye.